All right, good morning, everybody. Let's see, panelists. Okay, everybody's getting their video going here. That's wonderful. Excellent. Yeah, so good morning, everybody. It's exciting to be here at the 10th Summit.
Jesse, you've muted yourself.
All right, there. Now I think I got it. You know, Sunday morning, I don't think I was quite ready. So, all right. So welcome, everybody. Here we are at the 10th Summit. Very exciting to be here. I've been coming to the summits for a number of years. I've been here previously. It's always been an exciting event to be a part of. And it's been exciting over those 10 years to watch the progress of VR and AR and how they've evolved and how it's a technology that really is coming into its own. And we certainly have a great panel today to be able to talk about the variety of types of progress that are being made in this space. So I thought I would start maybe with Yasser. Could you give a little bit of background of the kind of work that you do?
Certainly. Good morning, everyone. It is a pleasure to be here. Thank you for the invitation. The work that the Facebook Reality Lab in Pittsburgh is focused on is very much related to what we're trying to do right now. We're all in different locations, different time zones, and we're trying to have what would have been ideally an in-person conversation. You know, we would have all been in the room together with you, the audience as well, experiencing and interacting as we would. Unfortunately, because of distance, it's difficult to do. And our focus is to enable remote communication that would be indistinguishable from a real one. So in other words, we'd all put our headsets on in the various cities we're in, and it would feel as if we're in the same room together. Our avatars would look, they would move, they would sound exactly like we do. And that's a challenge that spans a number of different areas of research, including, of course, computer vision, computer graphics, machine learning, but also audio research, because it depends on how you sound, how the sound travels in the room around you, how you hear it as you're in different places in the room. But it touches upon hardware, sensors, it touches upon displays because it has to look realistic as well. So it's one of those hallmarks of AR and VR where to really solve problems, it brings together many different interesting disciplines across computer science and engineering generally. So that's our mission. We've been on this journey for a few years. We've had some interesting breakthroughs, but most of the work is still ahead of us. So Jesse, I can share a video if that's all right. If I share my screen, is that all right?
Yeah, that's fine.
Yeah, let's see. So this gives you. Can you see my screen now?
Yeah.
Yes.
Yep.
So this is an example of myself wearing a headset, been augmented with a few sensors. This is Danny Belko in our lab as well, and she's wearing a few sensors as well.
Yeah, one of my former students.
One of your former students, that's right, Jesse. And so I'll play this and you can see how it feels in as an interaction.
Well, what can your face do? Can you show us?
Well, I've always hoped you would ask me that question.
Mm-hmm.
So I have some pretty good, I think, mouth movement.
How about your eyes? Can you look left, right, up, down? Good.
Yeah, I can be surprised. Ooh. I think one of my favorites is puffing my cheeks.
The mouthwash commercial.
Mm-hmm. And rolling my tongue.
That's pretty good, actually.
Yeah.
Good.
And just to conclude, where we're headed is to, of course, take this to the rest of the body, the hands, the face, the body, the background, acoustics. And this is something which we developed. I'll play this one.
Facebook, and I came across this video of this girl I went to high school with, and she's like, here's my attempt at beatboxing or whatever. And there was like 3 people. I didn't know who the other 2 were, but there was like one person.
So here, the face, the hands, the body, the background, all of this is rendered and in real time. Right now, there are, of course, many challenges in compute, and we're collaborating with Vikas and his excellent team on how to accelerate these as well. But that's a quick gist. You know, we're trying to see if we can move this to something that can be viewed on device in real time, and create ease of exploration, ease of creation of these avatars and experiences. Thank you.
Okay, great. No, that's you guys continue to make such exciting progress in terms of the avatar capture. Just so our panelists know, the video might have been a little choppy. I think that had more to do with the playback. You know, in real time, it's completely smooth, and and it's quite incredible to see that. Okay, Randy, can you talk a little bit about the work that you do with Virtual Heroes?
Absolutely. So good morning, good afternoon, and good evening, probably to everybody joining the session today. Right, my name is Randy Brown. I'm the director of the Virtual Heroes division at a company called Applied Research Associates. We were a small business founded about 14 years ago. We've been part of ARA for quite a few years now, and we create content for training and education purposes almost exclusively in the commercial, medical, and the government spaces. A lot of work that ARA does is in the DoD space in the United States. And so we're applying technologies in the VR and AR spaces to try to solve problems for users, a lot of times in, as they call, operator or maintenance scenarios, where there's significant training needs for very complex systems that they're interacting with, or very challenging environments, say in nuclear facilities and things like that. And then working to push this capability, as they call it, downrange, so that you can support soldiers in the field with augmented reality and virtual reality technology.
Great, and you'd sent a video, which I think I can play if I get all my share screen stuff right here. Give me 1 second, just get that going here. Should be right here.
So while he's getting this set up, it's the Virtual Tactical Assault Kit. There's a whole ecosystem of systems and software called TAC, and we've created the VR version of TAC.
Great, okay, I think this should be all set. You guys can see this, I think, so I'll play it here. All right, that's
short and sweet.
yeah, that's an intense video, Randy.
Yeah, we wanted to cover a lot of ground, but didn't want to waste people's time. So
all right, no, but it certainly gives a sense of the sorts of things you do. And of course, at Virtual Heroes, I know you do a lot of work for DoD and military. But my understanding is you have some things that are sometimes more industrial oriented. Is that right?
that's right. We're doing a lot of work in, like I said, industrial environments. We've done training even for the International Atomic Energy Agency, for example, like I said, for nuclear facility inspectors. And we're doing work where you have commercial environments for what they call mission critical operators. And there's a lot of folks who have to run data centers, have to run HVAC systems for, biotech facilities and things like that. And so it's really when you're trying to throw curveballs and challenges at learners in a spatial experience, and they really need to understand the environment that they're going to have to be working in. And so being able to recreate that for them and give them a wide range of challenges and problems to solve, and embedding all the procedural activities that they have to perform.
Oh, that's great. So Vikas, can you talk a little bit about the work you've been doing in augmented reality?
Absolutely. And good morning, good afternoon, and good evening as well. Yasser gave a very good introduction of what Facebook Reality Labs is all about. Specifically, I lead the technology on augmented reality. So just to give a little bit of overview, the thought process is that, every so often we see an inflection point in how we use the technology. So if you go back, 40, 50 years, we came up with the laptops and desktops where we interacted with keyboards and mice. And that's changed, in early 2000 when we had smartphones where we started looking at, touch and zoom and pinch on the device itself. And we, sort of hope that in another decades or so, it will be a very different way of interaction with our devices. It will not be through explicit way of, touching and zooming and pinching, but more contextual. So a device like an augmented reality glasses is the way to go. This is our belief. Something like what I'm wearing. This is not an AR glass, but this is the kind of form factor we want to get into. So with all the sensors that exist in these devices, we should be able to do a lot of cool things with machine perception, with understanding humans in the understanding the context. So we are building technology to enable all of that from both hardware and software and making sure that they can work seamlessly. And there are a lot of use cases, right? I mean, in terms of social interactions, which Yasser touched upon, holographic calls where you almost see people, your loved ones in front of you, improving things like your visual acuity, superhuman hearing. So there are a lot of technologies that we can bring to the table, which will help users see the world in a very different way, in an augmented way. So that's all AR is all about. And we are in the early innings of this work. There's a lot of work that needs to happen from technology side, from engineering side, and also from social acceptance side. So it will take us a while to get there, but the work that we are doing in that particular domain at Facebook is really at the forefront of the cutting edge.
No, that's a great description, and it is interesting how VR and AR are really in a lot of ways very different, but in a lot of ways seem to be converging in ways that we're all still trying to figure out. I can talk just briefly about my work. I was the previous creative director at the Disney Virtual Reality Studio back in the 90s. And about 20 years ago, I came to Carnegie Mellon and started teaching about virtual reality and also opened Shell Games, where we've been doing a lot of virtual reality development in the realm of entertainment and education. You can see some of the examples of different virtual reality experiences that we've created there. Of the current virtual reality market. Okay. Apologies, I'm having a little Zoom problem here. Okay, I guess I'm still going. Sorry, I was getting all these notes from Zoom saying Zoom has crashed, and I was a little alarmed by that. But I guess it was not crashed.
We saw it for a second. It popped up for a second. We did see the Zoom crash thing.
Yeah, I was like, uh-oh.
If you do that share again, I bet it would work. I mean, we got to see the games on the screen for just a second.
Oh well, look. All right, I'll try that a second time. We'll see. We'll see how that goes. Yeah. All right. So I guess sounds like we got it this time. Anyway, just a variety of different things, because what we've found is that there really is an emerging entertainment market now for virtual reality. The Oculus Quest system has really broken through and is starting to sell millions of units. And we're starting to see virtual reality entertainment go really mainstream, which is going to be interesting for both entertainment and education purposes. So to get into some of the discussion here, there's an awful lot to talk about, and I think one of the big things to talk about is to figure out where is this as a technology going in terms of both VR and AR. So I guess I'd like to start just talking about virtual reality. I mean, I can say we see it now having some impact in the entertainment space, and we think that's going to continue to grow. I'm curious, what do people think the industries that are most likely to be impacted in the nearest term are in the next say 3 to 5 years, the ones that are going to see the biggest impact?
I can go first.
Sure.
So I do believe, as I was mentioning, that these sorts of interactions, this is something where there's a real need, particularly with the pandemic. I'm sure all of us have been exposed to kind of the blessing of Zoom. Like there are all these activities we just wouldn't have been able to do had Zoom not existed, but how limiting it is in terms of connecting with people, having functional teams, and also like enjoying the company of others. So I think that's one space where if we can make a few breakthroughs over the next few years, I think we may be able to see that as a major emerging application space. And related to that, there are many other sorts of derivative applications. For instance, education is a pretty big one among them, right? MOOCs were supposed to sweep universities away, but they didn't. And of course, they've had a massive impact, but the reason why they haven't, a lot of people speculate, is because there is a strong social aspect of being with other students in a classroom and with a professor and learning with your peers as an experience. So education, I think, is one other area where I expect this will have an impact. And then finally, sports, gaming, entertainment, you just mentioned, Jesse, even going beyond virtual worlds, but more things that involve physical exertions as you would have in sports. I think there'll be much more of a shift in that direction. I expect there are other areas like in medicine, psychotherapy, physical therapy, and rehabilitation, but perhaps some of the other panelists can speak to those.
Oh, yeah, that's so it's interesting, Yasser. A lot of people think of virtual reality as an isolating technology because of the way you kind of enter into, a little bit of a pocket world there. But you're talking about using it, your work centers on, pardon me, breaking through into turning it into a more social medium than the one that we're actually in right now.
Yeah, I totally agree. Like when you look at a VR headset, it looks like it's isolating you. But I feel like that view that this is, one in a line of technologies that will separate us is profoundly mistaken. It's sort of a progression from the telegraph to the telephone to video conferencing. This is the next. It has the potential to be the next thing in terms of making it indistinguishable on how you're interacting, so that you're not separated by this glass wall that we have all between us. We can share a space together. We can point to things. We can look at the same things. I can look at you and communicate to you, Jesse, I'm looking at you right now, and not at Vikas or Randy. And then when I do look at them or they look at me, that's a signal that I communicate. I make eye contact. These are just fundamental, basic things about an interaction that are missing. As powerful as VC is, they're just missing from it. And it makes it harder to connect and communicate with people.
Gotcha. Randy, what are your thoughts about some of the near-term changes that we're likely to see? I know that in terms of military training, VR has been used for decades now. So what are some of the changes that you're observing?
Well, yeah, so certainly in the training space, I mean, that continues to evolve. The capabilities of the systems are really, when you start to get to a lot more of the higher end systems that can now replicate a lot of the displays and things like that, say in, military equipment and vehicles and airframes and things like that. You've just never had the fidelity that was sufficient for those systems to really be able to be used, to replicate, a real life experience. But I agree with Yasser that there's the ability from a collaboration standpoint, kind of a co-creation and collaboration standpoint around, even in, say, the DoD space, around equipment, around maintenance scenarios, around operational experiences. And, the advantage that we see with a VR system being on par with more of the standard platforms, Windows-based or maybe even a tablet or phone, is that it gives you the lot greater ability to have a different perspective from all the other teammates, and you can provide a level of advantage from that standpoint with, sometimes people would call it a God's eye view or something like that versus a boots on ground approach. And so having that strength of visualization to collaborate and communicate with your team in real time is something that's really, really I think pushing things forward pretty quickly. And, with these form factors, I had two Quest 2s delivered yesterday. So yeah, I'm excited about that, and, the form factors getting to the point where we can, expect that these things could survive in an environment that has limitations on, what they call SWaP, size, weight, and power, right? That's, one of the targets, certainly in the DoD space. And, really these systems come down to, kind of a low SWaP platform that a lot of people are willing to accept. So that's one of the real keys. I mean, obviously getting to the point, of having something that you can put on your glasses will be the ideal. Or better, go to contact lenses and, et cetera, just keep going. But certainly for now, it's already cleared a massive hurdle from, the last, 10 or 15 years.
Yeah, for people who aren't familiar with these, I have this is an Oculus Quest 2 right here. These are, now relatively inexpensive, about the same price as a game console, and completely wireless, which is been more of a breakthrough, I think, than people had realized. We're really seeing that the not having even a single wire makes a tremendous difference with both the hand controllers and with the headsets. So it's interesting, going to be interesting to see. Initially, this is largely used for entertainment. To the extent that these similar platforms are going to be adopted into training, into education, into business is going to be interesting to see.
Yeah, and with that, just one note on that, a lot of people see a platform like that versus, systems with the lighthouse emitters and, fully censored environments and say, okay, that's a limitation because, hey, I can't track my hand behind my back, or I can't, I'm going to lose track of some of the inputs. At least in our space, a lot of the things that are more procedural, operational, or, even maintenance, your hands, you're not doing something like this when you're trying to perform those tasks. So it's not a restriction.
Yeah, no, the experience I had, because one of the distinctions we make in the world of VR and AR is we say inside out tracking versus outside in tracking. So outside in is when you have an external camera of some kind, right, that you use in order to track yourself. But these have, you can see 4 tiny cameras on here. if the filter will settle down, you
right.
can see kind of 4 tiny cameras on here that do all the tracking, not only looking at this space and then using it to orient with 6 degrees of freedom in the space. So they're kind of looking at the space, locking onto the space, and then using it for that. But then also tracking the controllers. The controllers have no cameras on them, but instead have a series of hidden LEDs that these cameras are looking at, and so that you get very accurate tracking. And like you say, the question of like, oh, what about when my hand goes behind my back, goes out of view? Of course, what are you doing back there? Anyway, that's one question. But then secondly, with a game I was very worried about, we created a game called Until You Fall, which is a sword fighting game. And with a lot of big movements and swings, right? And so you're doing all this big motion, and we were very worried about the case where you like pull back and then swing in, and would we lose track of your hand? And we found this largely was not a problem. We were quite stunned initially when we worked on Until You Fall. We assumed, oh, it's going to have to be on PC to be able to go on any of these mobile VR platforms. I don't know if we're going to be able to get it to go there. And we were quite amazed that not only have we been able to get it to go there, but it plays incredibly well. And when in terms of selling units, we sell more units on the mobile VR platforms than on the Quest platform than we do on all the other platforms put together. So it's really clear that that's a big wave of the future in terms of near-term VR. So Vikas, I wanted to just shift to talk about AR a little bit. Right now in the sort of present day AR world, there's a lot of question about where things are going. We have things like augmented reality on our phones, that while it's functional, has not really made, it hasn't become something that's very mass market. In a lot of ways, there was a lot of talk of it being a really big splash and a game changer, and we've seen has been kind of peripheral. Then we've seen things like Google Glass and Magic Leap, where they've taken big steps to try and get headsets into people's lives, and they haven't quite found a way to gel. In industry, I think that's different. I feel like we've seen some success in industry with HoloLens, and now there are, of course, people discussing, the aforementioned cameras that are on here. There's some discussion of, maybe a good way to do augmented reality is just to use a VR headset and have very strong cameras so that you're just looking at the world through cameras and augmenting that way, as opposed to a pass-through approach that many systems use. So it seems like there's kind of a volatile potential set of futures for AR. Do you have thoughts about what are the technologies that are likely to be next, and what kind of influence are they going to have?
Yeah, that's a good question. I think with AR, one thing that we have to make sure that it's socially acceptable sort of form factor that we want people to wear, right? So when you talked about phones and them enabling AR technology, it's sort of weird to see people walk around with phones in their hand and start to see the world in a different way. So it's a good starting point, but there is only limited things you can do with that. And I think where we are going with that is, once we have the technology really the way we see it in our hands or on our faces, you really don't want to distinguish anything very, very different in how people are using that, right? So VR is a technology which you mentioned that can make it happen, but then it has certain limitations. We don't want people in real world walking everywhere with a big headset, right? I think it can enable the technology, but it has certain aspect of social aloofness that we don't want to get into, and by the way, VR is great. I mean, we use it all the time for our team meetings. So when we started work from home, we are doing Zoom like what we're doing now, and after a while we moved to VR meetings where we have a team of like 25-30 people, and we are easily able to get together and have really fun time discussion, pointing at whiteboards and things like that. So that's a technology that's really doing well, and I'm very excited. With AR, we see more of a social interaction. And there's also an aspect of like how heavy these things are, because after an hour or so, at least with my glasses, it starts to become a little bulky and wearisome. So I think there is a path for VR to become lightweight, and I think there is a lot of roadmap that exists, at least within Facebook, where we are getting to that. With AR, I believe once we get the right technologies in, where we can enable all of these perception cameras to work seamlessly with the audio technology, and all of that needs to happen locally on device within the glasses as well. And so there's a lot of compute that needs to happen. So we need to enable all of that as well before it becomes mainstream. So again, I mean, if you really fast forward 5 years, 7 years from now, we do expect the AR technology to be completely seamless. Like this meeting that we are having right now on our laptops and Zoom screens will happen me sitting somewhere where I can see all of this virtually on the screen, a pass-through screen. And that's a vision that will take a lot of technologies to come together to make it happen. But at least where we are seeing the path, there is definitely a path, and it will require work from industry, academia, and people all over to make it happen.
So I don't want to get too technical, but of course it's Carnegie Mellon, it's the Carnegie Mellon Conference. Let's get as technical as we want, I suppose. In terms of the types of display for pass-through, that has definitely been one of the significant challenges that we've seen. We've seen systems like the Meta 2, which used kind of a more reflective type projective system. And then we've seen systems like the HoloLens that feature more of a quantum waveguide system. And Magic Leap had originally touted something other than a quantum waveguide, but then they've ended up going basically in a very similar direction to where HoloLens went. And HoloLens and Magic Leap seemed very constrained by some of the same questions of that a colored waveguide is a challenge, because the nature of waveguide technology distorts color. And so you end up with having to do a multiple layered approach, seems to be what most people have tried, where you have to do a red layer and a green layer and a blue layer. So now you have multiple layers of complicated business. And then you have this problem of a rather small field of view is what many of these systems have been plagued by. There's been a real challenge in getting much more than a rectangle about this big in which you can render, which can be limiting for many applications. If you're trying to really fill in an environment, when I put on these glasses, I'm trying to, for example, say I'm at an oil rig and I want to kind of augment everything. I can only augment within this little zone. And the dream is, of course, to be able to pull that out to fill my whole field of view. Do you think that do you feel like you're seeing progress in that area, that we're likely in say five or so years to see real improvements in that area?
Yeah, that's the vision, right? And you rightly pointed out that display technologies for AR is a big challenge. And there are a lot of things that you mentioned. Quantum waveguides is one that's looking very promising. However, even with the idea that if you have a small field of view right in front of your eyes, you can still enable a lot of applications, right? Of course, the vision is that you should be able to completely augment your full field of view. But even in a limited scenario, let's say if you have a small area, you can still make it useful. Like I'm in a business meeting and I'm able to see a certain graph right in front of my eyes, or I'm walking around and I can put a name to a face, right? I mean, those are the kind of things where you don't need very extensive full-on display which covers all the field of view. So what you will see is a progression of technologies, right? So for AR to become mainstream, you don't really need, full field of view, display scenario where you can display everything. But even if you get to a point where the fidelity of these display are close enough so that you can't really differentiate real and virtual world, that will be a great start, right? And to get there, it's still a little while from now. But we are quite hopeful that we'll get there, and the technology will keep improving over the next decade to make it real augmented world as we want to see it.
Yeah, no, it's fascinating because part of, in many ways, I think AR is a much more difficult technical challenge than VR. Since VR, we don't care quite so much about the size of the headset, and we don't expect a VR system to have to interact with the world in the same way. One of the phrases we often use is augmented reality is better when it augments reality, right? We see a lot of applications that just make an object floating vaguely in space in front of you, and that's of some questionable use. When you have the most use is when the physical environment around you is actually augmented by virtual objects. But for that to happen, we need technology, sort of a room solving, space solving technology that understands not only where I am and what the objects in the room are, but how they're shaped and how to kind of connect to them. And so but it's fascinating because it's this number of technologies. AI solving for rooms. 5G is something people have talked about a lot, just as Google, has kind of revolutionized maps by having cars drive down the road and capturing everything with LiDAR. The idea is, what if everyone was constantly wearing a headset with little cameras and capturing everything about the world and building a giant database of the world that we could all use to augment? Obviously raises incredible privacy concerns about when do the cameras go on and off, but the idea that we could have that data and make use of that, but combined with battery issues, combined with display issues, all of those technologies are advancing. So it's just fascinating to kind of think.
Yeah, and just I want to comment on that. Like even in a simple example that I mentioned, which is putting a name to a face, a lot of technologies need to come together to make it happen, right? So you need display that we talked about. You need graphics rendering. You need maybe even eye tracking to figure out who you are looking at, right? So that it doesn't start popping names on every face that's in a field of view. You need wall locking so that if the person moves, then it moves with them. You need depth estimation so that if somebody comes in front of them, you want the annotation to be occluded as well. So there is a lot of things that need to come together, even for a simple example like that, and they have to all work together concurrently. And we want most of them to happen with the user device as well, without sending the data to the cloud. And that's what makes it more challenging because of privacy reasons, because of latency reasons. We want all of that to happen, on the user glass itself. And this is where a lot of the work will go on in the next few years in making sure that our hardware and software work seamlessly together in giving you that experience.
Yeah, I also wanted to comment. It is interesting to me. Like it's one of the biggest lessons I've learned since working in this area, is how incredibly interconnected these problems are. Right. I completely share Vikas, your optimism about the like the progression of technology. It will of course get wider in its field of view. It'll get better in terms of compute availability. But how interconnected these are, right? So even in a social interaction, the field of view, you may think you just need to see the other person's face. But then the peripheral view often tells you who's switched their head to look at someone else, or if someone's kind of like had a kind of a smirk or has pulled back a little bit, that information sort of shifts your gaze to look at them as well. And even with VR, where the field of view is kind of like, it's not as small as AR is right now, it's wider. It still feels like you're looking through kind of binoculars in the room that you're in. You mentioned, Jesse, that the size of VR doesn't matter as much as an AR, and that's true. But how long you can stay in the headset. Ergonomics matters so much in terms of interactions, especially as you're moving around. So the number of things are interconnected in terms of, as you had mentioned, Randy, size, weight, power, compute. Vikas, you mentioned that as well. Acoustics, vision, learning, AI, you had mentioned, and these are not kind of like incidentally related. They have to be co-designed, which makes the problem space so interesting and also and so complex at the same time.
Interesting. Randy, I'd be interested to hear your thoughts about some of the technical barriers that you think are that need to be solved. What do you think are some of the most important problems to be solving in the next few years?
Well, so speaking from the areas that we're working with, there is a really significant need to be able to widen that field of view for the types of tasks that we're trying to solve. At least in the DoD space, for example, the IVAS systems where they're testing with HoloLens 2 systems today, but there are other headset systems that are out there. For someone who's quote unquote going into the field, the field of view is critically important, and it is extremely difficult with these very narrow field of view systems to be able to deploy something that's going to be successful. There's a very large element of peripheral vision that's critical. Just as much, you could say that in entertainment, in a game standpoint, you can put some things in place to try to inform the player of what's going on. But the risk versus reward scenario in there is, okay, your buddy got fragged or something, but it's not real world. So, there is a real key push here to be able to access, as wide a field of view as possible. Not so much in the VR space. That's the other kind of nice thing we joke about it. Our consumer base in this regard is somewhat of a captive audience. If they have to wear the headset for 3 hours to get the job done, well, okay, they'll do it, right? And you're not. It's not something that's on offer from an entertainment standpoint or an ad hoc situation. So that's kind of funny. We can wave off some of those challenges and say, okay, they're just effectively not there. But some of the specific technological advances that may not be as critical to be able to collaborate with a group in a social environment or for workspace issues or things like that definitely come into play. And then the other element that we see is haptics, and that's just a whole new dimension for the force feedback of interacting with objects and the need to be able to have a reasonable feedback system. And, people are working with different glove-based controllers and things like that, and a lot of experimentation, which has been going on, for years and years, but a few of them out there with the haptics gloves or VR gloves, different brands out there. That's a real key element, because a lot of the activities that are being performed in these spaces have a very important tactile element. I mean, again, simple, when you go to maintenance training and you want somebody to understand the amount of torque that they're going to apply to a bolt to reassemble, you know, a system or something like that. We have what we call a part task trainer, where you're changing out the front tire on a helicopter airframe, and you know, all of the different elements, removing the nut, removing the washer, removing the bearing races, removing the whole wheel, remove and replace, reassembling, installing a cotter pin. Okay, a lot of those things can be done, and you don't need to necessarily understand the forces, but the critical elements of torque or something like that. And I think I'm really excited to see where this goes and the solutions that come together for it, because I think it's a huge challenge. I mean, it's all the way back when I was in grad school in the late 80s, we had force feedback arms with very powerful cables and motors, and you had a dead man switch that you stood on while you were operating the system, because this thing had enough force to be able to push you back, you know. But of course, you know, it's the sort of Damocles, you know, kind of systems here with these massive systems hanging, you know, bolted to the ceiling.
Yeah.
You know, that's not something that's all that portable. So there's elements here from the haptic standpoint. There's elements from the field of view that I think are a little more critical in these areas than they may be, you know, with people trying to solve other problems.
Yeah, no, the question of touch is an incredibly important one. So much of the way, you know, a lot of the power of VR comes from just the way you can kind of pick up and interact with virtual objects in a way that with flat media, you can't do anything like that.
Yeah.
But then, of course, the question of what's the best way to provide that tactile. Right now, the standard is to kind of have controllers and to be able to, you know, press buttons and things, and at least you have the tactile feedback of like pushing a button and you know you've pushed it. But many people are experimenting with empty hand systems, some kind of, you know, Tom Cruise like I'm grabbing things and dragging them around, which seems like a beautiful dream, but at the same time, not getting that tactile feedback is very dissatisfying, even though as natural as it might seem. So it's you know, the thing I always suggest to people is, you know, if you've ever had numb hands or had to wear thick gloves and try and manipulate things and how clumsy you feel, that's kind of the problem. When you have no tactile feedback, that's the universe that you're operating in. So there's the number of dimensions of problems to solve in virtual reality and augmented reality, I think, are what make it so fascinating, and that there are such human-oriented problems. It's all about the mind and the body and the eyes. So there are so many interesting things to solve.
Yeah.
So
It's a lot of fun.
I was thinking at this point we might open things up to the audience, to the participants, if people have questions that they would like to ask. I think you can drop them into the chat or use the question system, or not exactly sure which one's working, but I'm sure something's working. So if people have questions and would like to put them in, please go ahead.
While we're waiting, Jesse, I was wondering what your company, Shell Games, was one of the earliest game companies to start adopting VR. And it's been now a few years, and I wonder if you could comment a bit about how you see the gaming industry's response to AR and VR over the past couple of years, and where you see it going.
Oh, yeah, sure. No, I can talk about that a little bit. Apologize, audience. You may not actually have permission to kind of submit questions or use the chat, but I'm sure our wonderful tech support will give us a smart answer about what our next step should be with that. Yeah, in terms of where things are going in the game industry is very interesting. So for the past 5 years, most of the game industry hasn't taken virtual reality especially seriously. They've seen it as experimental, as something that may work, may not work. And it's tough because in the game industry, we have a lot of technologies that have showed great promise and then haven't really gone anywhere. A great example would be the Microsoft Kinect, which had been That had been something that had been greatly promised. Microsoft promised that in the future we would have no more game controllers. We would just play games with our hands somehow in front of the, we wouldn't have remote controls, we wouldn't have any of that. And they seem to really believe this. And they sold millions of units, but then people were quickly disappointed with what was actually possible. So I think, particularly because VR has had a little bit of a rocky start in recent years. We saw a lot of hype and a lot of promise, and kind of the number of people jumping on board and being delighted by it had been a little rocky at the beginning. But we really have crossed a threshold now, and we're seeing people are, millions of units are being sold. And part of it is just when people go into gaming and entertainment experiences, they're looking for a kind of escape, right? They're looking to go to somewhere new, somewhere different, have something, a powerful emotional experience. And the thing we always say is that VR is not a technology for the eyes, it's a technology for the body. It lets you create this feeling of your body being in another place, which can be really powerful. And so I know my prediction in terms of where I see it going, we're definitely seeing growth in this space. I don't think VR is going to completely take over the gaming industry, but I do think it's going to become a major platform. I would predict that by around 2025, 2026, that VR may be 15% of the revenue of the gaming industry, which, it's not as big as mobile. Mobile's maybe 50% of that, but still 15% will be a really healthy part of it. And I think it will be important because the VR experiences will be the most intense experiences because of the way they kind of involve your body and yourself, not only just the physical things that you're doing and the things that are coming near you, but in terms of encounters with other characters and with other players are going to be more emotional and more interesting.
Yeah, I agree. Definitely the emotional element of it, I think, is the key there. You get this opportunity for such a significant amount of immersion. I mean, look at what we've accepted over the last 100 years with moving pictures. We're just watching a movie, and everybody has signed up with that. And look at the emotional rides that we've been taken on, still just sitting there staring at a flat screen and having decently good, in some cases, if the theater's any good, a decent sound system to try to surround you. But I mean, the platforms, from, like you're saying, over the last decade or so, as VR has really started to accelerate, I think just has a huge opportunity to make a much more significant emotional connection. And that's what I'm looking forward to is the Oscars for emotional connection on a VR platform, right? Just let's put one of those together.
Yeah, the combination of AI combined with VR coming together, like once we're to the point where we have characters that are with you, that digital characters that can not only, characters can speak, no problem now, but they can't listen. When they can listen and have a full natural conversation loop, not a crude one like Alexa and these smart speakers, because those things, you talk to those like you talk to a dog, giving it, you give it commands and it does it. You don't have that natural loop of conversation. That'll be a huge change when that starts to happen. So we've got a question in the chat here from Ning Li. Could you name the key hardware components, innovations, and breakthroughs that are needed to bring AR and VR to the next stage? So there's a really concrete one. What are some of the hardware innovations that we need to see that are going to cause breakthroughs?
I can start with that just to give my perspective, and then other people can chime in as well. So one of the key challenges in any of VR or AR is how lightweight we can make these devices so that people don't even feel that they're wearing them, right? I mean, that's the ideal goal. But for that to happen, a lot of tech has to go in place. I mean, we talked about waveguide display. I mean, right now it's a bulky thing. Can we make it smaller, tinier, and give us like bright display with wide field of view? So there is a lot of work going on in that technology. But in general, also, sensors that we have, which we have a lot of them on these devices, can we make them smaller and make them smarter? So in many cases, we don't want these sensors to capture data and then send to some other compute engine to figure out, well, hey, if there is anything interesting happening. So bringing the compute in sensor or near sensor is going to be a key research area as well that we need to work on. AI is going to drive majority of these things. So again, how well do are we capable of running AI use cases on these devices locally? So there is a lot of work happening on that front as well. So we talk about AI from the perspective of large data center type acceleration, but there is a huge amount of opportunity that exists in building really an AI based system that's contextually aware of what's happening around you. So Jesse, you mentioned Alexa and other systems where you have to explicitly ask to do something and it looks very prescriptive. But where we want to go with AI is like you have all of these sensors that are telling you interesting things about the world around you, right? From visual, from audio, from even IMU and accelerometers and things like that. They exactly know where you are, what you are doing. And based on that, can the AI make decisions on what needs to happen, what you need to see, what you don't need to see, how you want to augment the world versus not augment the world and things like that. So there's a huge amount of opportunity in all of these areas from hardware perspective.
So question here about the spread of 5G. Is that likely to have an impact near term on VR and AR? Any thoughts on how 5G might change things?
Yeah, in my view, it would be fundamental. So latency is kind of one of the key elements, and it'll help with VC, but it'll help in a very big way with social presence as well. One of the things you can imagine is like if we were actually in a VR room together, there was Jesse's avatar, Vikas's, Randy's, and we were having this discussion, and suddenly the connection started to glitch. And Jesse started to just jump between states one after the other. As jarring as it is with VC, the degree in which that would disturb you if there was an avatar there, it would be much more fundamental. Or if someone dropped in and dropped out, dropped in and dropped out. The suspension of reality. I think having a secure, low latency connection is going to be one of those thresholds, Jesse, that you spoke about, right? Like that'll change the question of adoption. So I think 5G is one of the key technical developments, along with displays, along with compute, along with sensors, that we'll need to make this really kind of the next level of communication.
Let me push this. A technology that's been floating around trying to make itself useful for about 20 years now is the idea of cloud rendering. So the idea that instead of having to have a graphics card near my person that is rendering the display, that can be out in the internet, some server in a closet somewhere is doing the rendering, and then zap, the images are being sent to me, which that works fine if you're watching a Netflix movie, but the loop of latency that has to be so small and tight between when I start to turn my head and the image changing, it needs to be on the matter of less than 10 milliseconds. Does anybody feel like it's going to be conceivable that will be a useful solution within the next 10 years, or will the latency always just be too long? Because that would be an obvious way to solve it and have super light system, because I don't have to do any local rendering. Do people feel like that's near term?
I think the right way to think about it is the way Vikas has been describing it, is that there will be compute on your glasses, there will be compute in the cloud, and even the cloud, it's kind of like a generic term, but that can have components which are sort of like in close proximity to you, in your city, in your block. They can be at the city level, and then the
edge computing, some people call it.
Exactly, right. So, and it's kind of like a continuum. And I think the right way to think about it is as distributed compute. How can we design our AR/VR systems that can exploit the degree of computation on board, proximal cloud rendering systems, distant ones for some other types of compression and processing? So we should think of these as kind of like a dynamically changing distributed compute infrastructure. And then the key question is, how do we minimize latency and maximize quality? Like what distribution of computation would allow us to do that? It's challenging because traffic varies dynamically as well. So we have to, I mean, it's a very interesting computer science challenge once again. But that needs to be solved, I think, for this to be viable, especially for this case of weight.
And just one more thing that I want to add to that, it's not only about latency, it's also about power, right? So, sending data across wireless link is expensive as well, right? I mean, if you take a look at what does it take to do, a multiply accumulate on an 8-bit data locally versus sending that data through wireless link to the cloud, it's a few orders of magnitude more expensive to enable that wireless link and start communicating. So while cloud could be cheap because it's far away from your device, but I think even then it's expensive to communicate through the wireless link. So we have to be cognizant of that as well.
No, that's a great point.
I also wanted to, sorry, one quick one on latency. I think in literature, they often say that for VC, 120 milliseconds is sufficient. Like users don't recognize differences below that. But a lot of cognition, like a lot of perception is not conscious. We're not able to perceive how much of a difference it's making. My suspicion is it's much, much less than that.
Oh, I mean, this is a thing we know intimately in the video game industry. The first real breakthrough on this was, this is going to sound a little crazy, but it was maybe 20, 30 years ago. The game Virtua Fighter created a breakthrough in the arcade industry because previously video games rendered at 30 frames per second. That was the norm, right? And Virtua Fighter did an experiment where they said, what if we did it at 60 frames a second? Would players be able to tell, or is this a waste of technology? And because Virtua Fighter was a game all about fast action and quick feeling, everyone could tell. You put them side by side, 30 versus 60, everybody could tell. And when we're talking about 30 frames per second versus 60, we're talking about going from 30 milliseconds down to about 16 milliseconds. And so when we talk about, less than 100, like, I mean, a good rule of thumb, I think, is if it's more than 100, it seems broken, completely broken, and below 100, functional. But in terms of something that actually feels fluid and real, it's got to be way less than that. Anybody who's at a computer right now, if you pick up your mouse and you just move it back and forth, and you see all those like boop, 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 it's not a smooth connection at all. What you're looking at is 60 frames per second, and that's not fast enough. Like that's at 16 milliseconds, and so it's when you're talking about things that seem natural, it's amazing how tight those time frames need to be. Go ahead,
and you see the experiences where people have challenges, where look, we're researchers, we're willing to we eat our own dog food, as they say, and sometimes it might not taste so great, and in that case maybe something is only 60 frames a second and we're willing to deal with it. But to get broader based acceptance, we're seeing the push now 90 frames a second, 120 frames a second, and that really in some instances needs to continue. But when you're talking about this mesh of sensors and hardware systems, right, keeping those elements closest to the user that are critically important in your experience from an update standpoint, and being able to offload these lower quote frame rate calculations or issues that you're trying to address can help us work and use 5G in some instances to the cloud, but still have inertial sensors and equipment like that really needs to be tightly coupled to the end user. So I think there's a spectrum here, where certain things can operate at much lower update rates, but there's certainly room for improvement in all those areas.
I'll give you my pitch right now. This is going to revolutionize AR. Is transparent lithium, so that the lenses of your glasses are the batteries, and that's that. There. All right. So someone out there can solve that. That would be great. Okay, another great question. Recently, we've heard extensive rumors around Apple entering the VR business with very high resolution, though very expensive headsets. So yeah, those rumors have been floating around. I'm curious, do people feel like if Apple drops into the world with some kind of VR/AR headset, Is that likely to make a difference? You know, and what kind of difference do you think that'll make?
Well, I mean, and I think, you start to get into high-end systems like you were just talking about, Jesse, the Quest, we can get these things for $300 or $400 nowadays, which is awesome. A nice lightweight platforms. I think, a lot of the higher end, there's certain utility for very, higher end systems, but I think it plays more into support initially, of course, into, industrial scenarios, commercial environments, or maybe, things in the DoD space where the cost of the end user platform is not nearly as much of an issue, versus the level of capability and functionality. And then, I think that will evolve over time to where you'll start to get broader based acceptance. But, it's orders of magnitude that need to be, brought down. Every single time we've seen platforms deployed commercially, at least from an entertainment standpoint, the price points are just so critically important to be able to get wide range acceptance. And so I think it could be something as a nice slow start, but my expectation is that you're going to have a few turns of the crank over time before you're going to get that down to a cost point, and a form factor that could really be consumed, by the point where we're getting to, like you're talking about with headsets nowadays, millions of units shipping, or are we going to go to the full smartphone analogy with billions of platforms over time? We've got a long ways to go there. We've already seen, 1 million times or 1 billion times improvement in the experience in VR over the last 30 years or so. That type of improvement is going to have to go a few more orders of magnitude before it's going to have broad-based acceptance, I think.
No, that makes a lot of sense. Okay, so we've got time for about one more question here. I'm very curious to hear people's answer to this. Someone's asking about what are the most important areas in industry or people's everyday lives that could be physically impacted by AR in the near 3 to 5 years. So I guess I'm going to ask this in a really concrete way. I'm going to ask all our panelists to imagine it's the year 2025, right? 4 years from now, 2025. And we already see games and entertainment. We see that games are getting some traction in this space, so that's likely to continue. I'm curious to hear people's thoughts about the most popular, most used non-game VR/AR applications in the year 2025. So what do you think when we look at okay, here's some of the most used, most popular, what's going to be kind of somewhere in those top 3, top 5 apps at that point, 4 years from now? And I'll start with Yasser. What do you think?
So I would predict 2 things. The first one is, not surprisingly, that we will be having some share of the communication activity. Of course, phone calls will remain, VC will remain, but some share of them will be happening in AR, as we'll have a group of people, we'll be talking to them with our glasses, spatialized in the world. And the other one, which I expect Vikas can speak more about, would be contextualizing information, right? Like as you're looking around, AI is analyzing the scenes for you, connecting it to your own knowledge and experience that it's seen with you, and giving you the context that you may want of objects in space embedded in it. So those are two areas where I think there's a good chance there'll be some share from AR/VR.
Okay, communication and visualizing spatial information. That makes sense. Randy, do you have thoughts about what do you think is going to be getting the most traction by the year 2025?
Yeah, so I'll put one out there. I think with what's happened with the pandemic over the last year, a lot of people have, looked at or questioned, am I going to go back to live events in the future? And so I think a key target is, sporting-based events where the augmentation with that contextual information in the actual live event is something that I think could really create a leap in the experience of sporting events. Anything from just the additional information that we get put up on the screen, during a basketball game, or the little arrows following a car during a NASCAR race or things like that. Just think about the richness of the experience that you could create in a live experience of that event. I think that's going to be a lot of the sport challenges to try to get people, quote, back in seats. And I think that's a massive opportunity in that space.
Wow, that makes a lot of sense. Vikas, what do you think?
So we talked about assistant, in the last few minutes, and I think in a few years' time, I expect the devices to really act as a digital assistant to us, who understand us so well that they are able to figure out, when do I need to record something if there is interesting happening in my life, or when do I need to be told something that, hey, you need to be here, or something else where if you're eating an ice cream, it tells you that, hey, this is going to exceed your calorie budget for the day, things like that, right? So this is where I see the future is, where you offload a lot of the mundane things that occupy your brain space and offload to these devices who understand the world as you see them as well, because they are sitting at the same vantage point, looking at the world as you are looking and hearing, and also the contextual understanding of where everything is happening. So that's what I see as one of the killer use case in some number of years from now.
All right. Well, so I really want to thank all our panelists for looking into a crystal ball and predicting the future for everybody. So if I'm understanding today's agenda, the person who couldn't be here today was Professor Chris Harrison, but he did put together a really interesting video, and his work is a fascinating complement to everything that we've talked about here, because he's talking about alternate ways to do augmented reality, sort of alternate types of displays. So very shortly, we're going to be looking at a video from him. But right now, a huge thank you to our panelists for coming out and having this great conversation. Thank you very much also to the organizers for hosting us. And a special thank you to Vikas, who got up at 5 o'clock in the morning on the West Coast in order to be part of this. So all right, so if I understand right, we're gonna jump over to a video now.
Good morning, everyone. Really excited to be talking to you at the 10th CMU Summit. Today, I want to give you a little bit of a sense of what's beyond headsets in augmented reality. There's more than one way to achieve augmented reality and the vision that it's putting forward. But first, a little bit of background on myself. I run a group called the Future Interfaces Group, and as the name suggests, we're thinking about what is going to be the future of interactivity in more advanced computing devices, and what that's going to look like in terms of the technology and also in terms of the human experience. And we tend to blend together, I would say, kind of three different areas to make innovations in AR and VR. The first is sensors and signals. We need to get interesting data in order to enable interesting new interactions. And then to make sense of that data and of those signals, we need to use computer vision and machine learning and other computer science techniques to really understand what's going on with the user. And then finally, a lot of what we do has to live in the real world. And that means we have to have a physical artifact that embodies that technology. What does a future smartphone look like? What does a future headset look like? And so we often have to go and physically prototype things if it's going to be used by a user. And if you kind of blend those different things together, we think we can make and unlock interesting advances in AR and VR. So just to give you a little bit of a sense of some of our projects, here's one project. In this case, we are using an off-the-shelf smartphone, so no special hardware here, just software. And what it does is it looks at LED lights that are in the environment. Many devices today include status LEDs, and obviously, lights on the street have lights as well. And what it does is it uses the high-speed camera to look at that light, fixate on it, and then also decode a binary ID. So here's just a quick demo video of that. And what you can see on the screen is what they would call a pass-through mobile AR experience. So in this case, we're sort of using the phone almost like a gateway or a window into this other dimension. And you can see here that as we hold up our phone to look at these various light sources, you can often see it blinking on the phone screen, but it's actually quite hard to see it blinking in reality. Human eyes are not quite that good. We can start to overlay interesting information. And importantly, a lot of these devices don't need to be smart devices. Like a power strip can tell you how many watts are being consumed, but it doesn't have to have any internet connectivity. It can express that information purely by using the LED and a very small microcontroller in the device. A very inexpensive way, maybe $1 per device to have this sort of augmented reality experience. And on the phone, it's just software only. So this is a form of augmented reality that's not headset based. We do things that are more, I would say, traditional VR/AR. In this case, this is a haptics project. And what we came up with was a ratchet mechanism that we can programmatically arrest. And so here's just a single one of these. In this case, we pull it to a very specified length, and then the motor stops it. And we only have to consume power at the locking interval and not beyond. And that's because obviously a lot of these headsets are mobile, and we want to be very cautious about battery life. So we can do this for one finger, as you can see here, or we can do it for every joint on the hand. And so this allows us to actually individually arrest each joint in the hand. So if we reach out, in this case, to a gray wall, our hand naturally becomes flat as we touch the wall and go flat. So we start to feel a physical surface. And this actually is true for lots of geometry. So we can actually do it for like a railing or even a complex sculpture and start to actually feel things in virtual reality, which is a significant problem. But what I want to talk to you about today is actually headsets. So when we think of augmented reality or virtual reality, we often think about people putting on some sort of a headset in front of their eyes. And I think this is a perfectly practical solution. The fact is we need to get photons into people's eyes, and the best and easiest way to do that with today's technology is to put essentially a screen right in front of their eye. But I don't see this as becoming a predominant way that people are going to be walking around the street, or at least not for many years to come. They're just too bulky and expensive right now to achieve that sort of widespread use. And if anything we learn from Google Glass is that even if the technology is sort of there can be pushback from consumers. So I don't think, I totally see people working at their desks like this. Obviously, if they have a specialty job, they're an architect or they're a surgeon, obviously, then it's totally acceptable. That's a tool for their job. Whether or not we'll be walking down, CMU's campus with one of these in the near future, I think remains to be seen. And so I think it's important to think about, are there ways to have augmented reality without wearing a headset? Could you have a dinner with your family and not everyone has to wear one of these headsets? And we do have good exemplars for how this has been done. So, we have, for example, lighting in our homes. This is a form of augmented reality. It is augmenting our reality with artificial light, and it's very much a technology. So in some respects, the incandescent light bulb and artificial lighting was the first augmented reality kind of technology, or at least a widespread one. And so this improves our daily life. It's definitely a technology that improves our existence, and yet it's very unobtrusive. It helps us without really getting in the way, which I don't think is true of current augmented reality. And you can think about your desk. You turn on maybe a light to be able to see your notes from class better. Fantastic. But this is a very kind of plain experience. Can we do better? And you might be thinking, well, we have smart light bulbs now, right? These are, here's an example from Philips. These change color. I unfortunately, I think that does not give them the name smart light bulb yet. In fact, I would suspect that Thomas Edison, who really kind of helped bring light bulbs to commercial fruition essentially 150 years ago, he would probably be very disappointed that all we've been able to do in a century and a half is make them change color. It's very minimal progress, in my opinion. I don't think they really earned the word smart quite yet. But we can think about, how would you make a really smart light bulb as a form of augmented reality? And so this is a topic that my research group has been thinking about for a long time. This is one of my former PhD students, Robert Schau. And he is literally, as you're seeing here, painting interactivity onto the walls of his office. There's a light bulb in this office, but it's a very special light bulb that's more like a digital projector with sensing. And this is an application he set a status meeting. So, is he in a meeting? Is he working? Or just knock on his office door? So now we're talking about almost a user-defined style of lighting, which is very different than how we think about lighting today. And here's what that hardware looked like back in 2013. So this is pretty old. This is 8 years old. And you can see it's very primitive. It is literally an off-the-shelf digital projector with an off-the-shelf Microsoft Kinect glued to the top of it, which is it's a type of depth camera. So in this particular project, we aim to push on the software, not on the hardware front. You have to sometimes choose your battles in research. But we nonetheless, after we showed that the software was viable, that you could turn just your walls into touch interactive sensors without having to modify them, just the light bulb, it got us really thinking. And so we spent year after year trying to improve the hardware. So here is our hardware a year later. This is 2014. You can see it's still off-the-shelf components, but they're smaller versions of those components. And then by a year later, we'd really start to make strides in miniaturization. So what you see here is now the depth camera and the projector is all together. And there is now a light bulb screw fixture, which we can screw into a standard light bulb socket. But there's wires running out here, and that's because the compute, to run our computer vision and our machine learning, was still so heavyweight, we had to run it off to a desktop computer out of the scene. So that's obviously not self-contained yet. But now, last year, 2020, we were able to finally put all of the technology pieces together inside of a self-contained unit. So what you're seeing here is sort of floodlight bulb size, and it receives, not only do you hang it in an environment by the screw base, but that's where it gets its power from as well. And inside of this 3D printed enclosure is a power supply that's stepping it down to the DC voltages that we need, a computer, a depth camera, and a projector, all together in one thing. And the idea is that we take this kind of smart light bulb, and you can go back to your desk, unscrew your LED bulb, and screw in our smart bulb, and now your desk can become an augmented reality experience. You don't need to wear a headset. So here is what that looks like. You'll see there's lots of little green dots. This is just for debugging. This is just to show you how the touch tracking is working. And you can see we can drag interfaces around, and we also look for snapping. So if we find a kind of an edge in the scene in terms of its depth, like that laptop, we can actually snap an interface to it. And then all of the apps are essentially just web applications. Web applications have been optimized to be dynamic in terms of their resolution and width. And so we're essentially running all these inside of a web browser, and we're sort of lying to the app saying, oh, you're running in a 7-inch tablet, or you're running in a 9-inch tablet, when in reality they're actually rendering on this ordinary wooden desk. And there's nothing special about this desk. It's just an ordinary table. And so we have to have behaviors like running away from mugs. Obviously we don't want you to put your coffee mug down and it starts typing into your spreadsheet. And we want to be able to support all of the standard multi-touch kind of gestures like pinching and zooming. Now, what's interesting about this kind of approach is that the digital projection is pretty much solved for us. We have to understand a little bit about the geometry of the table, so because we're never going to be perfectly perpendicular, so we have to do things like projection mapping, but that's not terribly hard to do. The hard thing is actually how do you track fingers on a wooden desk, for example? How do you actually do that reliably? How do you turn a desk into like an iPad? And for that we use depth cameras. I don't want to go into the algorithm, but this has required a lot of innovation on our team's side. And what you're seeing here is, again, just a research video. It's showing our method, which we call direct, and it's that solid green circle, compared to the 4 best previous techniques in the literature. And you can see that not only is our technique much more spatially accurate, it actually finds the fingertip, but it's also more stable as well. And so you can read the research paper if you're interested about how this actually works. So between projection and touch tracking, we think we can sort of start to put all the pieces together into essentially a new form of computing, this kind of light bulb computer that you could go to a hardware store like Home Depot and buy a 6-pack of these, and they would probably be running sort of a version of Android. They'd basically be like an Android smartphone, but minus the battery and minus the screen, and instead you're putting in a projector and camera. So we think we're getting pretty close to this point. Maybe next year, maybe in a couple of years, we have all the pieces ready to go. And we actually teamed up with an OEM, Beijing ASU, to produce the world's smallest projector computer combination. So this was kind of when we first published this research in 2018, it was definitely the smallest implementation and still largely is today. And what you're seeing here, all the pieces sort of exploded out. What you see here is a very, very small projector. It's a scanned laser pico projector. So it has a little tiny mirror that flutters back and forth many thousands of times per second to raster scan an RGB laser onto the environment. Here we have the main compute board. In this case, it's a quad-core CPU. It has a little GPU as well, which is incredible. At 4 gigabytes of RAM, it is a fairly capable computer. Modest, obviously it's not a desktop computer, but if you are clever with your programming, you can actually pull off everything that you need in this small, mobile-grade processor. And then my team contributed this component here, which is a very small time-of-flight-based depth camera, which we use for touch tracking. And we sort of exceeded our goals in many respects. We were able to get this to be so small that we actually decided to skip over making it into a light bulb and actually kind of go for broke and actually make it as a smartwatch. So what you see here is a prototype. Again, you could put this technology into a light bulb, but we said, hey, wouldn't it be fun if we could actually get augmented reality on your body? And so here it is running. You can see we can do the touch tracking. The projection is happening from the side here, so it has to be very oblique angle to be able to render it. And you can see the resolution is not amazing. It still is very much a prototype. But it shows that we're sort of getting close to where we might be able to have augmented reality experiences on the body. And this is a good thing because, while it's nice to have an augmented reality desk powered by, for example, a smart light bulb, when you get up and leave that desk, you've left that augmented reality behind. One of the nice things about having a headset, of course, is that it's mobile. The augmented reality and the extra abilities you have go with you as you walk down the street. That's not going to be true with smart light bulbs. And so it is interesting to think about, well, what does it mean to actually put the augmented reality on your body with projection as opposed to in front of your eyes with a headset? And this is a topic that we've been thinking about for a long time. So this is one of my first projects in this area called SkinPut. This goes back to 2010, a project I did with Microsoft Research. And in this case, we're doing touch tracking on the skin. We're doing it with acoustics though, not computer vision. So we actually have a sensor that sits on the skin and it sort of listens inside of your body, very much like how a doctor would kind of listen to your heart or to your lungs with a stethoscope. So we're listening inside the body, and when you touch your own skin, it makes a very distinctive sound. And you can sort of see there's this kind of goofy thing off on the side. In this case, this is where we're putting a projector, so it's sort of cantilevered off the arm. It's not particularly practical, but this is more than a decade ago. So then I went back to Microsoft a year later and said, let's try to make this more practical. And so you can actually see the hardware prototype near here now up on my shoulder. And this is now computer vision based using depth cameras, which is pretty much what all of the later projects have used as well. And we're able to support full multi-touch tracking on the body. So this is something that goes with you wherever you go, the ability to use your own body for multi-touch. So here's just some demo reels. Obviously, if you hold up your hand, we can have, for example, like a slide to unlock to be able to get to a phone keypad. But if your hand is too tiny, you could even grab something else. So if you happen to hold up a notepad or a newspaper, you can now use that full surface for interactivity. Or if you hold up your forearm, we can take advantage of that larger surface area. And same as if you walk up to a wall, there's no reason to constrain it to your hand. We can actually use that entire wall in front of you for multi-touch. So really, the system is looking and sort of hunting around the environment, saying, are you in front of a desk? Are you in front of a wall? All you have is your hand. Maybe you're sitting at a train station waiting for the train to arrive, and all you have is your hand. Well, then we'll use your hand, but it can be flexible in what it can project on. Now, a big challenge here is that because we're doing a computer vision approach, it's sometimes very challenging to know, is the finger actually touching the surface of the body or not? This is a big challenge from a computer vision standpoint because 1 millimeter above the skin looks very similar to touching the skin, 0 millimeters above the skin. And so you'll see in a lot of these kind of shots that I have to be quite generous. You have to lift off the surface quite a bit in order for the touch tracking to work well. And even still, you can see it's sort of an estimation. It's not as good as a real touchscreen. And so to solve this very particular problem, we teamed up with the Facebook Reality Labs office here in Pittsburgh, and we came up with a technology that really tried to solve this problem of how do you do very accurate touch detection on one's own body? Because we want to enable these sorts of experiences. And so what we did is we came up with a new type of wristband. So you can this is obviously a research prototype, but imagine this is like a smartwatch built into your smartwatch in the future. And what it does is it's emitting an electrical signal, an RF signal, and your body is acting as a waveguide. And what you can see here on the side is the little finger will turn red at the moment of touch. And that's because as soon as you touch your own skin, you're creating a loop, you're creating a circuit that we can detect. If you're even just a small fraction of a millimeter above the surface of the skin, you don't create the circuit. It's like having a light switch that's been, that's open. Only at the moment of touch do you actually get the contact. And in this way, it can be very accurate at detecting touch contacts on your skin. So just to kind of wrap up here, I wanted to kind of show you some of these research projects to give you a sense that augmented reality and even virtual reality doesn't have to be entirely headset based. I guess virtual reality much more has to be limited to headsets because you really do have to occlude the outside world to have that virtual reality take over. But in augmented reality, I really want to stress that there is numerous ways to achieve the vision of having computing sort of live in the environment, be in the ether, be always accessible, and not be trapped inside of a screen. And so in addition to headsets, I think we are going to start to see sort of smart light bulb kind of capabilities, and even maybe Warn projectors in the future. And it's not that any one of these is better or worse than another. They all have pros and cons, and as researchers, our job is to go out and figure out what those pros and cons are, to push the technology as far as it can, and sometimes it just ends up short. I will tell you that a big challenge with Warn projectors is competing with sunlight. When you go out into full sun and you have a projector that's worn on your shirt or worn on your arm or worn on your wrist, to compete with the lumens of the sun is an extraordinarily difficult challenge. It's even a challenge for headsets. You'll see that the HoloLens here uses tinted. It's basically wearing sunglasses, and that's also because the brightness of those displays, the contrast of those displays, isn't good enough to work out in sun. In fact, it's even hard sometimes to do it in a sunny indoor scene. And so they've included essentially sunglasses on their headsets. And so there's always going to be problems with each one of these approaches. But importantly is that in certain contexts, some of these approaches are stronger than others. And we want to have sort of an array of tools. It's not that when you're building a house, all you have is a hammer or all you have is a saw. Different tools are good for different things. They have strengths and weaknesses. So on that note, I'll end my presentation and thank you again for your attention and enjoy the rest of the summit.
Thank you so much for such a wonderful discussion. It was a really great talk about VR and AR regarding their application, breakthroughs, and prospects, and so on. Every one of these ideas are valuable and impressive.